Hello everyone, welcome to iQuanta. My name is Nitin. I'm sure all of you are doing great. Guys, this is the second video of synthesis. In this video, we'll be discussing one very important concept, some examples and some useful applications as well. So let's start with the concept. Guys, the concept is called conversion of the certain fraction into the percent. In the first video, I told you that how do we convert the fraction into the percent and vice versa. But guys, this time we are going to discuss, certain fraction conversion into the percent. Why we are going to discuss them? Because these can be asked directly, in the questions in the examination. So it's very important to remember those conversions directly, right? So let's start with those conversions one by one. Guys, usually, if you have to convert a fraction into percent, we just multiply by 100, right? Okay, suppose the first fraction we are starting is 1 upon 2. Okay, so what I'm going to do, I'm going to, keep the numerator as 1 and will be increasing the denominator, by 1 by 1, all right? Okay, 1 by 2 we all know multiplying by 100 will give us 50%, pretty basic, right? Okay, let's keep the numerator same and increasing the denominator to 3 now. 1 by 3 if you multiply by 100, this will be approximately, 33.33%. It's not going to get divided completely, I'm sure you know this. But in this chapter we can write the approximate values always. So if they are saying in a question 33.33%, we can say 1 by 3. If they are saying 30.34, then also, we can take it as 1 by 3. Okay, on the other hand, guys, we can also, call this 33.33 as 33:1 by 3%, right? This is also we should remember because in the questions, they can also ask the percentage value in this term, right? In the fraction term as well. All right, and if we should also need to remember some of their multiples. For example, double of 1 by 3 in fraction is 2 by 3, but in percentage sum should be 66.66, right? Okay, in fact, let us write this. 2 by 3 double of the fraction, double of the percentage as well, so it should be 66.66, right? And we can also call it 66 is 2, 2 by 3 percentage. All right, guys. Okay. Now, what next can we say here, guys? If we, keep the numerator as 1, if I increase the denominator to 4 now, right? So we can say what 1 by 4 is now half of 1 by 2. So half should be the percentage term as well. So half of 50 has to be, we can say 25%, right? Very simple as this. If you multiply 1 by 4 by 2, it should be 2 by 4. And 2 by 4 is nothing but 1 by 2. And 1 by 2 is also, we know 50%. So no need to write this again, right? If I multiply 1 by 4 by 3, it has to be, 3 by 4. 3 by 4, we can say triple of 25 as well, which is very easy, 75%, right? Now, multiplying this by 4 is, 4 into 1 by 4 is 1. 1, any value 1 in the fraction is 100% of itself. So, very easy. You do not need to, mention it here. All right, the next fraction in the series we can take as 1 upon 5. Pretty easy. Multiplying by 100 has to be, 20%. Such an easy conversion, we can say that. First we'll be doing easy ones, and then we'll be increasing the level of them as well, right? Okay, double of 1 by 5, by the way, is 2 by 5, and its percentage conversion has to be 20 into 2 is 40%, right? Now the triple of 1 by 5 has to be 3 by 5, and the right hand side has to be 20 into 3 is 60%, right? We can just say that. Then 1 by 5 into 4 has to be, we can say 4 by 5. And the right hand side is like 20 into 4 has to be 80%, right? Simple things. 1 by 5 into 5 is, again 1 which has to be 100%. No need to write here. Okay, the next fraction we can say is 1 upon 6, right? Now guys, 6 is actually a composite number. We can say 6 has a few factors like 3 and 2. So we can find the value of 1 by 6 either by the help of 1 by 3 or by the help of 1 by 2, right? We can say 1 by 6 is half of 1 by 3. In this way we can say that. So half of 33.33 has to be 16.66 as well, right, guys? Okay, which we can also write, if you have to write the decimal in the fraction, we can say this has to be 16 is to 2 by 3, right? And this should be, again in a percentage term. Okay, now if I do the double of this percentage, like we are learning the multiples of them as well. So guys, double of 1 by 6 is actually 1 by 3, which we already know. So no need to write this. If we do the triple of this, so this will be 3 by 6, which is also 1 by 2, which is 50%. No need to write again, right? If I do the 4 times of this should be 4 by 6, which you can also say 2 by 3. And 2 by 3 is 66.66. So no need to write one more time this, right? Okay, now if I do this 5 times, so it has to be 5 by 6, right? which guys we can also write as 1 minus 1 by 6, okay. See, either we can multiply this by 5 as well, 16.66 into 5, because this is getting 5 times, but multiplying 16.66 with 5, slightly calculative. So we can do one more thing. We can say 5 by 6 is 1 minus 1 by 6. Now guys, we know that 1 in any fraction is also equivalent to 100 percentage, right? Then 1 by 6 we can say is 16.66 percentage. Now 100 minus 16.66 has to be 83.33 percentages, which we can say, right? Also we can call this as 83 is to 1 by 3 percentage. All right. Now if you multiply this by 6, we have multiplied till 5. If you multiply by 6, so 6 into 1 by 6 is 1, which is obviously 100 percentage. So no need to write this here. All right, now if we increase the denominator, numerator is still 1. Let's say the denominator is 7 now, right? So guys, 7 actually is a prime number, like 6 was a composite number, so we use its fraction, its factors like 3 or 2. But here we can't do this because 7 is a prime number, right? So guys, what usually we can do, if suppose we do not remember anything, then remember how do we convert fraction into percent? By multiplying this by 100, right? So if you do 1 by 7 into 100, you will actually find 14.28 percentage, all right? Approximately, this is again an approximate value, right? 14.28 in fraction has to be 14 is to 2 by 7, all right guys? Now, remember I'm telling you way to remember every conversion, so there is also one of the trick to remember. But remember guys, this is just a trick, it has no logic, right? What is the trick? Trick is what guys, if you do 7 into 2, we get 14, right? If you do 14 into 2, we actually get 28, right? So this is one of the tricks we can say here, right? Okay, similarly, if we do, multiples of these fractions, so 1 by 7 into 2 is, we can say 2 by 7, right? So its conversion should also get double. So 14.28 into 2 has to be 28.56, which we can also write as 28 is to, 4 by 7 percentage, right? Okay, now similarly, if you do the triple of this, right, so what shall we get? We can say 3 by 7, let me write here, 3 by 7, if you do the triple of this as well, so it must be 42.84, right? And this we can also write at 42 is to 6 by 7, percentages. Similarly, we can multiply by 4, 5, 6, and so on, right? They all can be helpful in solving the questions. I'll tell you the uses of them very soon. Let's just finish those conversions. Then we'll also understand, its applications, right? And then you will understand that why are we doing all of this and why is it so important that we are, investing so much of our time into this. All right, let me tell you about 6 by 7 only, right? Because 6 by 7 is something which can be tricky for some of the students, right? Usually students do what? They say that 6 by 7 is, 6 times of 1 by 7. They try to, multiply the 6 times the right side as well, 14.28 into 6, but that will be slightly calculative. So you can do one more thing. We can also say 6 by 7 as 1 minus 1 by 7, right? Now 1 is again 100 percentage and 1 by 7 we can say is 14.28 percentage. And that difference will be how much? We can say that difference is 85.72 percentage, right guys? So this is how we can, understand or convert the multiples of 1 by 7 as well. Okay, the next one, the numerator is fixed and now let's say the denominator is 8, right guys? So 1 by 8 pretty easy, 8 is composite, 8 has a factor like 2 or 4, so we can use any one of them. Let's say 1 by 8 is half of 1 by 4. 1 by 4, if you remember, was 25 percentage, so this has to be half of 25. That means it has to be, 12.5 percentages, all right? This we can also write as 12 is to half, right? Okay, simple things. Now, if we do some multiples of them, 1 by 8 into 2 is 2 by 8, which is again 1 by 4, which is 25%. We already have done this, right? If you write the triple multiple of this, third multiple of this, which should be 3 by 8. Now, the right hand side should also be multiplied by 3. So 12.5 into 3 has to be 37.5, which we can also write as 37 is to half percentages, right? Similarly, if we do, 4 by 8, 4 times of this, so 4 by 8 is half, which is already we know 50%, so do not need to write here. If we multiply this by 5 now, it has to be 5 by 8, right? So 12.5 into 5 has to be 62.5. It's obvious, I'm not writing this. Multiplying by 6 has to be 6 by 8, which you can say as 3 by 4 or 75% as well. Now, last thing, let's multiply this by 7, 7 by 8. So right hand side has to be 12.5 into 7, which you can say 87.5%, or we could have done one more thing. We can also say 7 by 8 as 1 minus 1 by 8, just like we did here, right? 1 minus 1 by 7. We can do the same thing here as well. We can say 1 minus 1 by 8. 1 is 100 and 1 by 8 is 12.5. So 100 minus 12.5 should be again 87.5 percentage, which we can also write as 87 is to half percentage. All right, guys. Okay, now moving ahead, we have done up to 1 by 8. The next one we can say is 1 upon 9, 1 by 9, we can use it with the help of 1 by 3, right? So 1 by 9 is 1/3 of 1 by 3, right? 1 by 3 is 33.33. 1/3 of that has to be, we can say 33.33 by 3 is 11.11 percentages, right? Okay, we can also write this as 11 is to 1 by 9 percentage, right? All right, now guys, if we do the double of this, so it must be 2 by 9, left hand side, and the right hand side has to be 11.22 into 2 is 22.22 percentage, right? Which we can say further as, 22 is to 2 by 9 percentage. Similarly, we can do the triple of this, which is 3 by 9. 3 by 9 is again 1 by 3, which is again 33.33, so we do not need to write that. 4 times of this is 4.9, we can say has to be 4 times of this, which means 44.44, or 44 is to 4 by 9. And in the same way, we can keep doing the things. Let's write the last one as 8 by 9. So that is 8 times of 1 by 9. That means 8 times of 11.11 as well. So 11.11 into 8 has to be 88.88, right? Which we can also write as 88 is to 8 by 9 percentage. All right. Now, guys, let's talk about the next fraction, which we can say is 1 by 10. But you know what, 1 by 10 is pretty easy. 1 by 10 should also be 10%, is very simple. So we do not need to mention this here. Let's discuss the next one, right? The next one has to be 1 by 11. All right, now guys, 1 by 11, 11 again is a prime number. You can see that, so it doesn't have any factor behind. So what can we do here? Again doing the same thing, converting the fraction into percent by multiplying by 100, right? So if you multiply 1 by 11 into 100, it has to be 100 by 11, and 100 by 11 has to be 9.09. If you do, you will actually find it, right? But you know that I'm telling you the trick to remember all of them, so there should be a trick for this as well. Actually, yes, right? What is the trick here? Okay, just a sec. It's just like we wrote about that 1 by 9 is 11.11, right? So we can actually connect 1 by 11 with 1 by 9, right? How? Okay, let's observe one thing, guys. When it is a 9 here, it comes 11, all right. And similarly, look at the percentage part of this. When there is a 11, we can say here is 0.9 or 9. And again, when there is 11, there is 0.9. So this is how you can remember this trick. Okay, this is how we can understand that how this conversion can be remembered for the future. Simply, guys, its decimals fraction should also be written like the same. If you do this, you will actually find this is 9 is to 1 by 11, right? And you can remember this part also in the same way. Look at this fraction and this fraction. 11 is now converted into 9, and 9 is now converted into 11. So the thing is that 9 is being converted to 11, 11 is converted to 9, or you can say 9 and 11 are getting interchanged with each other, right? This is how we can remember this thing. All right, so this is how we learned 1 by 11 as well. Now let's do the double of this. So we can say 2 by 11, doing the multiples of the same fraction. 2 by 11, the right hand side is 09.09 into 2, has to be 18.18, all right, which we can also say that 18 is to 2 by 11. All right. Similarly, guys, if we keep doing the things, right, in the end we can say what? Let's do 10 by 11, all right. Either we multiply this by 10, or we can do one more thing. We can also write this as 1 minus 1 by 11, means 100 minus 9.09. I think easy would be to multiply this by 10, and that should be how much? Multiplying 9.09 with 10 has to be 90.9 approximately. All right, guys. And right hand side, the fraction form, we can also say that is 90 is to 10 by 11. Alright, guys, so these are few important conversions. There are few more which we will learn in the next slide. Alright, the next one guys, we have done till 1 by 11, right? The next one is 1 by 12, right? So 12 is again a composite number which can have factors as 6, 4 and 3 and 2, right? Let's use 6, right? 1 by 12 we can say is half of 1 by 6. 1 by 6 we just did, you know, in one of the previous slides, that was 16.66. So half of 16.66 has to be 8.33 percentages, right? Which you can also say as 8 is to 1 by 3, right? We can also say this as it's 8 to 1 by 3. Okay, simple. Now guys, if you do the double of this, so 2 by 12, which can also be written as 1 by 6, and 1 by 6 we know is 16.66, right? Now, doing the triple of this is 3 by 12, which can be written as 1 by 4. 1 by 4 is again 25%. We know this. No need to mention this again. Doing the 4 times of this, 4 by 12 is 1 by 3, 33.33. We know this. Do not need to mention that. Then 5 by 12, right? You know, multiplying this by 5. So it has to be what? If you multiply this by 5, the right side should also get multiplied by 5. So it should be how much? See, it's difficult calculation, right? So guys, we can do one more thing. We can write 5 by 12 as 6 by 12 minus 1 by 12, you know. And then what can we do? See guys, 6 by 12 we can say as half, right? And 1 by 12, we just learned it today. We'll be writing it soon. So 1 by 2, we can further say as 50%. Very simple. And 1 by 12 is nothing but 8.33%. And subtracting them, we'll get how much? 50 minus 8.33, we can say 41.66 percentage, or we can also write 41 is to 2 by 3 percentage. So guys, this is how, you know, we can convert some difficult fraction into percentages as well, right? Okay, there can be more multiples of this, but I'm sure you can do them just like we did here, all right? So let's now do the next fraction here, keeping the numerator as 1 and increasing the denominator by 1 as we are doing it, you know, since 1 by 2. All right, 1 by 13, guys. Again, you know, 13 comes a prime number. So here is a problem again. Okay, guys, 1 by 13, what shall we do? Whenever we get a prime, we can't use the previous fractions. Simple thing we can do what? Again, converting the fraction into percent, we can multiply by 100, right? So guys, once you do multiply this by 100, you know, you will find that is being 7.69 approximately, right? Most of them are approximate values, I'm sure you understand. Okay, we can also call approximately 7.7, 7.68, you know, if in the exam it's coming 7.7, 7.71, 7.68, all can be referred as 1 by 13 because they all are the approximate values, right? We can also say this as 7 is to, you know, 9 upon 13. Okay, now the trick, you know, I'm telling you the trick for all of these conversions, whether they are simple or not. So the trick of this is, again, a very interesting trick. And again, guys, remember, this is just a trick, no logic at all, right? No logic, no concept. So what is the trick? Let me tell you this here. See guys, usually when we convert fraction into percent, what do? We multiply this by 100 and we know that, right? So it must be 100 by 13. 1 by 13 into 100 is 100 by 13, obviously. Now, we are not going to divide it completely. We'll be just writing the integral part of this, right? So guys, 13 7 is 91, right? Closest. 13 8 is 104. We can't take that. So 7 times is getting divided, right? Now comes the decimal part, which we obviously do not know, and that we can also calculate, but it will, you know, take some time to calculate. So there is a trick to find, you know, the decimal part actually. What is the trick? See guys, we are doing, you know, 1 by 13, right? So let's find the square of 13. 13 square, I'm sure we all know, is 169, right? So the last 2 digits of 169 will come into the decimal part of this, right? So this is the trick which I was talking about, right? What is happening here? That the last 2 digits of the square of 13 becomes the decimal part of this, right? Decimal part of this percentage conversion. So this is how you can remember this, you know, conversion. And remember again, guys, this is just a trick to remember. This is not a logic, right? All right. Now the next one is 1 by 14. All right. We are not doing the multiples of them because they are not as much, and even they are as, I'm sure you will be able to do because we have learned a lot of, you know, multiples of a lot of fractions earlier. Okay, 1 by 14, guys, we can say this as 1 by, you know, half of 1 by 7. 1 by 7 is 14.28, so half of this has to be, we can say 7.14, right? Which we can also say as 7 is to, we can also say 7 is to 1 by 7, right? Okay, Multiples of them, again, slightly easy, so I'm not doing them, all right. Okay, so next one we can say is 1 upon 15, all right. And 1 by 15 we can say is nothing but 1 by 3 of 1 by 5, right. We can say 1/3 of 1 by 5 or 1/5 of 1 by 3, both can be taken here, right. Suppose I'm doing 1 by 3 of 1 by 5, 1 by 5 we know is 20%, and 1/3 of 20 has to be, 6.66 percentage, which we can also say as 6 is to 2 by 3 percentage, right guys. We can write this as 6 is to 2 by 3 as well, and we can do their multiples as well in a similar manner, right. Okay, the next one is 1 by 16, which we can remember with the help of 1 by 8. 1 by 8 guys is what? Is 12.5%, we just in the previous slide. So this is half of 1 by 8, that means the percentage should also be half of 12.5, that means it has to be 6.25 percentage, which we can also write as 6 is to 1 by 4, alright. Okay, guys, you must be thinking that these are being so many, right? So don't worry, I'll tell you some more tricks to remember them, don't worry, right? Okay, the next one is 1 by 70. Let's write this here only, right? Because only 2 are left, okay? Among the important ones, only 2 are left, and we'll be covering only 2 more, right? So guys, 1 by 17, again, 17 comes a prime number, right? So whenever there is a prime number, we are in a problem, right? A small problem, right? Okay, so 1 by 17, again multiplying by 100, so you will find this as 5.89 percentage, all right? We can also write this as 5 is to 15 by 17, all right. We can also call this 5 is to 15 by 17. Okay, how to remember this, right? The important part. So guys, good thing is what? That the trick of 1 by 17 is same as the trick of 1 by 13, right? That's the good part. What is the trick? Let me tell you. Let's just repeat it. So first thing, just write the integral part of this, conversion. It has to be 100 by 17 percentage. Now guys, 17 5s we know is 85, right? We just know that, and not finding the decimal part, not calculating the decimal part. The decimal part will be coming with the same trick, writing the square of 17, just like we wrote the square of 13, all right? 17 square we all know is 289, okay? So the last 2 digits must be the part of, the decimal, all right? So we can say what? This is how we can remember 5.89, right? Just like 1 by 30. Okay, the last one is 1 by 18. Okay, it's 1 by 18, we can say that this is nothing but half of 1 by 9, all right? Okay, so 1 by 9 is nothing but, we just learned it today, is 11.11, right? So half of 11.11, you can say approximately 5.55. It's not the exact value, it is the approximate value. And once you simplify this, it will be 5 is to 5 by 9, all right? Okay, fine guys, so this is how, we are able to convert all of them, right? Convert all the important ones, right? Okay, now what is the next thing? Next thing, first we'll be learning some, examples of this. I'll try to explain you why they are so important with the help of few examples. And then we'll also be doing some, applications. First, let's do some example to understand its importance, right? Okay, so guys, the first example in front of us is that to find 8.33 percentage of 156. Now, you might be thinking that this is a weird, decimal, such kind of decimal will be asked in the exam or not. So guys, actually they can be asked, In fact, most of the time such kind of decimals are being asked, right? Okay, now guys, suppose we do not know all of this what we have learned today, right? Suppose we do not know these conversions, then whatever we know till now, so what we would have done, we might have done 8.33 upon 100, just like we do in a school, right? Or we might have done with the help of splitting, so we can say 8.33 as 8 plus 0.33, but both are actually, the lengthy ways, right? So here comes the conversions. We just did 8.33 today. 8.33 is how much in fraction? It is 1 by 12, right? I know it's difficult to remember just now, right? So for now, guys, you can keep watching the table. You can actually note down all of these conversions in a note, and you can keep watching those conversions by the help of your notes, and keep solving the question with the help of watching them. Don't worry, all right? So 8.33 you see is 1 upon 12, okay? Writing it 1 by 12, so what shall we get? We can say this is 1 by 12 of 156, right? Now guys, 156 is actually a multiple of 12. if you try to calculate, you will find it, it's getting 13 times, so we get the answer 13 directly, If we did not know this, then also we might have got the answer, maybe the approximate answer, but it would have taken a lot of time. With this method, we can solve them so quickly, right? Okay, the next one is 22.22. Guys, this is also we have learned today. 22.22, if you remember, that's nothing but double of 11.11, right? It's nothing but the double of 11.11, right? So we can say this as 2 into 11.11 percentage of 198. If you do not remember it directly, then you can do like this, okay? Now 11.11 we know is 1 by 9, so we can say this is 2 into 1 by 9 of 198, right? Now 198 upon 9 has to be, we can say 22, all right? And 22 into 2 has to be 44 later on, right? So this is how we can say it has to be, 44, the answer of this, right? Okay, the next one is 32.5% is, now guys, if you remember all of these conversions which you have done today, in fact we can see them, so you will find that we haven't done 32.5 at all, even not the direct one, not even the multiples of them. You can check, neither of the multiple is 32.5, right, in this slide as well, none is 32.5, here also none is 32.5. So what should we do here? See guys, such kind of fractions or percentages can also be there. So what should we do whenever we are getting confused, we are not able to solve? So we should try to split it, maybe the splitting works, right? So to check the splitting, you should actually see the decimal part, right? So you see that the decimal part is 0.5. 0.5 decimal part we had in 12.5% is actually, right? So that can actually help us. So we can break this in such a way that 12.5 should be one of the part of 32.5 breakings, right? Actually, it's become very easy because if you split 12.5, right, you will still have 20% with us, right? That's it. That makes the things easy now, right? Most of the time, whenever they are giving the questions on splitting, they make sure that this splitting does not become too difficult. Otherwise, it will be difficult for the students to solve this as well, right? So they make sure that it shouldn't be that much difficult that it becomes difficult to split them, right? So you see that that was not as difficult as splitting if you just know the sum basics. As I told you, looking at the decimal part and all, so it will become easy for you, right? Okay, doing the final part, the calculation one. So guys, we can say what that 12.5% we just learned today is 1 upon 8, right? 20% is 1 upon 5 of 160, right? Now let us do both of them one by one. So we can say 1 by 8 of 1 by 60 first. So 160 by 8 has to be 20. Then 160 by 5 has to be, we can say 32, and then the sum has to be, 52. This is what we can say here, right? Okay, so this comes 52, and this is how we got the answer of third example as well. There are a few more examples, right? Let's finish them as well, all right? Now, these two examples are a bit different. It says the question like that, find this number is what percentage of this. So these kind of questions we used to do in school a lot, right? What was the formula to this? Let's say guys, if they're asking that find that a value A is what percentage of another value B, so we can write this as A upon B into 100, we can write this as A upon B into 100, okay. Now, either you write A upon B into 100 or you can just write A upon B and then find its percentage conversion. That can also be, the same thing. So this is what we are going to do here. Will not be, multiplying by 100. We'll be just writing the fraction of this A upon B, and then we'll be converting the fraction into percent as we did it, as we learned the conversion here, right? Okay, let me show you one example and then I can elaborate more. So question number 4, example number 4 is that find 14 is what percentage of 154, right? So we'll be just writing 14 upon 154, right guys? Now, if you observe that 154 is actually 11 times 14, right? So this can be simplified as 1 upon 11. Now, in school we used to do 1 upon 11 to 100, but today we just learned that 1 upon 11 is 9.09 into percentage. So we can just write 9.09%. And that's it, right? We can just write it like this, and this is, the correct answer, right? So this is how, guys, we can save a lot of time if we do not multiply by 100. In most of the examples of such type, we do not need to multiply by 100, but suppose we are getting such fractions which whose tricks or whose which we have not learned today, or those are not that much important that we did not learn today, right? So in that case, guys, you have to multiply by 100. Don't worry, but such kind of cases will not be so many, so you do not have to worry much. Most of the time they give the fraction in such a way that their conversions are in a syllabus, and we have written all of those important ones here, right? Most of the one will be in the list which you have done today. This is what I wanted to say. All right, now the next one is that find 30 is what percentage of 105. So guys, the same step, a upon b, 30 upon 105. So you can see that both the numbers are the multiple of 15, right? So this has to be 2 upon 7. Next thing we can say, this is 2 into 1 by 7, right? Now guys, 1 upon 7 we all know is 14.28 percentages, right? So 2 into 14.28%, and it has to be 28.56%. Simple as this, right? So this is how we did these questions with so ease, with the help of these conversions which we have learned today, right? Okay, next are a few questions, but before that I want to tell you again that how important these conversions are. See guys, we need to remember both the things. We need to remember left to right as well, right? The fraction to percent and percent to fraction as well, right? We need to remember in both the ways, right? Okay, they look similar, but they are actually different when you start remembering them, okay, or using them. Fine. So I'm sure you understand that by the help of these conversions, we did, for example, so easily with so much of comfort. So one thing is sure, that these conversions are pretty important. Now the last thing, that how do we remember these conversions, right? So guys, one thing which we did today, right? We did a few examples, right? So guys, whenever you are solving any question, right, so do one thing, just do not do in the way we used to do before. Just try to use these conversions, even if you have to look at these notes to use them, but use them for sure. Suppose you are using it, let me take an example. If you are using 1 by 7 is 14.28, but you do not remember this, right? There is a question where 1 by 7 is required, but you do not remember its percentage value. So you can just watch your notes, just look at this and then solve like this in your question, right? So in this way, even if you are doing it twice or thrice, maximum 3 or 4 times, you have to copy it, or you can say see with your notes. But guys, trust me, after that this will get into your mind. You will not have to go to your notes again, right? So this is one of the ways, like the practicing. If you will be doing so many practice of these conversions, trust me, this will get into your mind, and you will be able to then you will able to solve the question in this method. All right, and second thing you can do, what okay, there is a small exercise which you can do. Just like guys, today I have told you a few examples, right? So you can also make some example for yourself. You can actually give some question to yourself, right? Okay, you can do what? Let's say you want to start from 1 by 6, right? So give yourself few examples in which 1 by 6 is important. For example, you can say to find 16.66% of a number, right? And then you will be using 1 by 6, and more you will be writing this, more it will get into your mind. Simple. Then give one more example to yourself to find 83.33% of something. Then 83.33% is 5 by 6, right? Then give few more examples for 1 by 7, right? Let's give an example to find 14.28% of a number which is 105. Okay, then give another example of 2 by 7 and so on, right guys? So in this way, if you keep writing these conversions, trust me, it will become something which you will always be able to remember, right? Okay, so hope this trick will help you, and you will be doing it, right? Unless you do not do, obviously it will not be helpful. So you have to do some exercises which I just told you right now. Now coming to the word problems, because guys, ultimately they will be asking the word problems in the exam, right? In our syllabus, arithmetic is asked only in the form of word problems. So let's do some word problem. In word problem, understanding the language also becomes a challenging part. Right now I'm not giving very difficult language questions, but we should start from somewhere at least, right? So let's start with one easy example. The example or question says that there is a class in which 14.28% students are boys, and the number of girls are given to us 300. Then we need to find the total number of students in the class. All right. Okay guys, the percentage is given for the boys and the number is given for the girls, right? Okay, before this I want to tell you one thing. See guys, just like in the last session, last video of percentage, I told you that the percentage share of the boys plus the percentage share of girls has to be 100. Very obvious, right? You know, the sum of the percentage share of all the divisions has to be 100. Very obvious. But suppose we have to do the in terms of fraction, then what? So guys, we can say what, that fractional part of the boys plus the fractional part of the girls has to be 1, you know. If you add the fractional part of boys or girls, or you can say all the, you know, sectors or segments, that sum of the fraction has to be 1, right? This is what we can say. Alright, so let's do the same thing over here, right? So they are saying what is a class in which 14.28% of the students are boys. Now we know 14.28% is nothing but 1 upon 7, right? So we can say the number of boys has to be what? 1 by 7 of the total number of the students, right? Number of boys has to be 1 by 7 of total number of the students, right? Now, if number of boys is 1 by 7, so guys, what about the number of girls now, right? We can say what the number of girls has to be, as I said, the sum of the fraction is always 1, right? So what should be the fraction of the girls? That we can say 1 minus 1 upon 7, right, of total number of students, okay? Now 1 minus 1 by 7 has to be what? It has to be 6 by 7 of the total number of students, alright? Now guys, the good thing is what? We know the total number of girls, right? That is why we were doing this, because we knew that the total number of girls are given. That's why we were finding the total number of girls with respect to the total number of students, because the ultimate question is to find the total number of students, right? Okay, so that was an approach, that was a strategy. Now, writing the number of girls, which is 300, okay, so we can say what? The total number of students has to be 300 into 7 by 6, simple. Alright, so what shall we say here? 300 into 7 by 6. 300 by 6 has to be 50, and 50 into 7 has to be 350, and that has to be the final answer. So guys, by the help of, you know, these conversions, we could solve this question pretty easily, right? If we are not using these conversions, right, we are solving with percentage directly, then also we can solve the question, but then it will take a lot of time, and also it will not be very much comfortable in terms of solving it, right? Okay, now on that note, let's try one more problem. Okay, question number 2. Again, a word problem. The question says that in a class there are 1200 students, out of which 33.33 are boys and 62.5% is girls got passed. So find the number of failed girls. Alright, see guys, in the last problem, you know, because I was doing something like this for the first time, so I wrote, you know, few extra lines, you can say that. You know, once you become perfect, you do not need to write everything, okay? So we'll try to avoid writing everything in this problem, okay? So the question says that there are 1200 students, the boys are 33.33, which is 1 by 3 actually, and among the girls, 62.5 got passed. Guys, 62.5 is actually, if you remember, 5 times so 12.5. 12.5 is 1 by 8, so we can say this is 5 by 8, okay? I know it's not easy to remember, you know, but trust me, if you keep practicing, it will, you know, get into your head, as I said before. Okay, this is 5 by 8, okay? So what about the number of failed girls? See guys, the number of failed girls, we can say what? See, the number of passed girls are how many? Number of passed girls we can say are 5 by 8. Simple as this, right? Number of passed girls are 5 by 8. So number of failed girls should be, we can say 1 minus 5 by 8 of the total number of girls, right? You know guys, among the girls, if you see, among the girls there are two kind of segments. One is about the passed girls and second is about the failed girls, right? So among the girls, if you add the fraction of the passed girls and the fraction of the failed girls, the sum has to be, you know, 1 again, right? That's why I did it like this. Sum of the fraction of the passed girls, which is 5 by 8, right? And of the failed girls should be 1. So to get the fraction of the failed girls, we subtract the fraction of the passed girls from 1, right? I'm sure you understand this. So finally we do the calculation part. See, I could have written everything again just like the last problem, because I wanted that you guys, you know, also do not write so many things. That's why I'm not writing each and every line in this solution, right? Okay, now 1 minus 1 by 8 has to be, we know, 3 by 8. So we can say this as 3 by 8 of total number of girls. But now guys, the problem is that we do not know the total number of girls, but we can find this for sure. See, the boys are 1 by 3, you know, 33.33 is 1 by 3. So the number of girls, I'm sure you can do it verbally now. It should be 1 minus 1 by 3, which has to be 2 by 3. Simple, right? So 3 by 8 of the total number of girls, and total number of girls, as we just discussed, has to be 2 by 3 of the total number of students, right? And total number of students are given to us 1200. So finally we can say this as 3 by 8 of 2 by 3 of 1200, right? 3 by 8 of 2 by 3 of 1200. Okay, it's a good thing that 3 got cancelled out, right? And 2 8 is like 4, 1200 by 4 has to be, we can say, 300. And this is how we can solve this question. The number of failed girls came to be as 300, right? I hope you guys understand this. Now coming to the third question of the day, right? This question is very interesting, right? The question says that in a class 16.66% of students are boys, and among the girls 6.66 have got failed, right? Now find the number of students in the class if the number of passed girls are given to us 84. Alright, see guys, we can do one more thing. We can solve this question by assuming the total number of students as x, like we used to do in a school, right, in primary classes. But in that way it will be very lengthy, right, because we will be doing each and every step, right. First, with the help of the total students, we'll be finding the number of boys, the number of girls, then among the girls the number of failed girls, and then the number of passed girls, and it will take a long time. So we'll do what? We'll try to do the things a bit directly, right? But how? See guys, in such kind of question, do one thing, just try to make a relation between the data which is given and the data which is being asked, right? That means the data which is given is the number of passed girls, and the data which is being asked, that means the total number of students. So we'll try to connect a relation between these two. How? Okay, I think, hope you understand we can do this just like the last problem, because in that also we did the same. We got the relation between the number of failed girls and the total number of students. So the same thing we can do here, right? How? Okay, see guys, we are asked the number of passed girls, right? Okay, first thing, what about the failed girls, right? See, if you think about the failed girls, so the fraction of this should be how much? See guys, the percentage is 6.66, right? 6.66, I'm sure you remember we did it today. It has to be how much? See, this is half of, you can say what? You can say this is 1/3 of 20, right? And 20 we remember usually 20 we remember usually 1 by 5. So this should be 1/3 of 1 by 5. That means this has to be 1 by 15, right? Okay, what I did, 6.66 you can say is 1/3 of 20, right? And 20% is 1 by 5. So 1/3 of 1 by 5 should be 1 by 15, right? So guys, among the girls, 1 by 15 are the failed girls, right? 1 by 15 are the failed girls among the girls. So among the girls, a passed girl should be, we can say 1 minus 1 by 15, just like the previous question. Sum of the fraction has to be 1. So we subtracted the fraction of the failed girls from 1 to get the fraction of the passed girls, right? Okay, of, the total number of girls. Now, we can do one more thing. We can, do the next step in the same line, okay? See guys, the total number of girls, what can we say? See, the boys are given to us as 16.66%, which we know as 1 by 6, right? Which we know as 1 by 6. So if the boys are 1 by 6, the girls has to be, 5 by 6. Or you can also say 1 minus 1 by 6, because the fractional part of the boys and girls has to be 1 again, right? Okay, so 1 minus 1 by 6 of the total number of students. So guys, you can see this. This is how, we found a relation directly about the information which is given, passed girls, and about the data which is being asked, the number of total students in the class, right? So this is how we can solve this question, in very less number of lines, okay? Fine, let's do the final part. Number of passed girls is given to us as 84, right? Now, 1 minus 1 by 15 has to be 14 by 15, right? Into 1 minus 1 by 6 is 5 by 6, all right? Of the total number of students, fine. Now, it's just about, some simple calculation, right? So we can say what? The total number of students has to be 84 into, we can do it 15 by 14, right? And into, we can say last is 6 upon 5. We are just doing the cross multiplication, that's it. Okay, so look at this. 84 by 14 is actually 6. You know, usually they give such kind of numbers that they get cancelled out, and we just get the easy number in the end. All right. Now in the end, what we can say, 15 by 5 is also 3. So 6 into 3 into 6 will give us how much? 3 into 6 is 6 into 6 is 36. 36 into 3 we can say is 108. And this is how we can say the total number of students in this class is equals to 108. All right, and this is how we are able to solve this question number 3 as well. All right, so guys, this is all for this session number 2 of percentages. In the next session, we'll be coming up with more important concept of the same topic, percentage, with some important applications, and we'll be discussing some previous year questions of IPMAT Indore as well very soon. All right, guys. Till then, I'm sure you all will be keep studying. Just keep working hard. And if you like this video, also write your feedbacks in the comment. And if you want me to do something else, right? If you want to give any feedback, as I said, write in the comment box. And then now we'll be meeting in the next video. Thank you.